and welcome to this video where we're going to look at square and cube roots. Okay, here's the symbols for this square and cube roots. This one here is our square root, and this one here is our cube root. You'll notice the cube root has this 3 at the front, square root has nothing there. It technically has an invisible 2, but that's the two different signs. This is what our square and cube roots mean. So if we have, it might be helpful to start in this column over here. Here we have 4 squared. If we square 4, we get 16. A square root is to undo this operation, so it's to go backwards. So a square root of 16 is going to give us this number here, which is our 4. A cube root is the same thing, but with cubing. So instead of squaring, we go 2 to the power of 3, which gives us 8. A cube root undoes this operation here. So we get the cube root of 8 equals 2. One sort of question we could be asked relating to square and cube roots is to find out which two whole numbers the square root of another number lies between. So we don't know, we can't just look at the square root of 10 and tell what its square root is, because it's not one of the standard numbers that we would do that for. But we do know that the square root of 9 is going to give us 3. And then if that's 3, the square root of of 4 is, the square root of 16, sorry, is going to give us 4. And 10 is between 9 and 16. So we can say that. So therefore, the square root of 10 lies between 3 and 4. So here we know that, while we don't know what the square root of 10 exactly is, we know that it's somewhere between 3 and 4. Have a go at this question. Okay, so we don't know what the square root of 30 lies between, but we think of numbers close to it. I think of 36. So the square root of 36 is 6. Now 36 is bigger than 30, so we'll go down 1. So the square root of 25 is 5. And 30 is between 25 and 35. So we can say, therefore, the square root of 30 lies between 25 and 36, between 5 and 6. Another thing we might be asked is to use a factor tree to determine if the number that we're given has integer or whole number square roots. So every number will have a square root, but it might be a number like 3.721. We want to know if it's a whole number or not. So we can make a factor tree. So we already know how to do this. So 21, we have the factor 7 and 3. That's as far as that one goes. We can see that these two numbers aren't the same, and we can't get two numbers that are the same there. So we can say that this one doesn't have integer square roots. It'll have a square root, but not an integer one. Now with 25, we know that we can go 5 and 5. We can't go any further. Now these two numbers are the same, so we can say that this one does have integer square roots. We won't do 9 because that's much the same. We want to use 16. So 16, we could go 8 and 2, 4 and 2, and 2 and 2. Now, hopefully you realize that 16 is 4 squared. So the square root of 16 is 4. The square root of this one is 4. However, we don't have 4 appearing there twice. But if we look here, we have 4 2's. And we can make that into 2 pairs of 2's. And we know that 2 times 2 and 2 times 2 is going to give us 4. So if you can play around with these prime factors and make numbers that are the same, you're going to find that that number up here does have integer square roots. So 16 here does have integer square roots. We can also do this with cube roots. So 8, you can go 2 and 4, and 2 and 2. Now we end up with 3 2's at the end. So if we go 2 times 2 times 2, we're going to get 8. So know that this one does have a cube root. 9, we can go 3 and 3, but that's as far as we go, so we know that this one doesn't have an integer cube root. Here's an example of some sorts of questions that you might get asked with roots, cube and square roots. Now, it's important to note that we still use the order of operations. And our square roots and cube roots are actually a form of indice. So our square roots all happen in the indices part. So we're going to use that bit of knowledge to answer these questions. So the first one, we have no brackets. We go down to indices. We have a square root. Let's make this number 9 actually to make it a bit easier for the sake of this example. So that becomes 4 times 3. And now we go down to multiplication. And we're going to get 12. So that's how that one works out. The next one, we're going to look again. We don't have any brackets, but we do have indices. We have this one here, and we have our cube root. So we're going to do those. So we get 2 squared is 4, minus our cube root of 27. Hopefully you realize that that's 3. If you get 3 times 3, that's 9. Times 3 again, you get 27. If you were to put the cube root of 3 into your calculator, you would get, the cube root of 27, you get 3. So now we have 4 minus 3. That becomes easy. We just take away, we get 1. And finally, we have this expression down here. Now, it's important to realize that we do this addition within this indice before we add the 8. Let's see if we can get rid of that. Yep. So what we're going to do, no brackets, we go down to indices. We want to work out what this indice is, but to do that, we have to add the 2 together. So we would get the square root of 9 plus 8. We complete our indice. We're going to get 3 plus 8. So we're going to get 11. It's important to note that the square root of 4 plus 5 does not equal the square root of 4 plus the square root of 5. If you do this, you're going to come into some problems. These two do not equal each other. That's a summary of what we looked at this lesson. I hope it's made sense. If you've got any questions, please bring them to me.